Hi and welcome to Thin Black Lines. In this video we are going to discuss how SQL Server 2014 in Memory OLTP achieves no lock, no latches, faster access of data. For better understandings, don't forget to watch SQL Server 2014 in Memory OLTP overview video. In SQL Server 2014 in Memory OLTP, data for memory optimized tables is not stored in data pages and extents. Rather, a specialized row structure is introduced. Just like disk-based table rows, every row in memory-optimized tables can be divided in payload, which will contain user data, and row header. Every row header contains begin timestamp, a timestamp when a row is actually created, end timestamp, a timestamp when a row version is deleted. It basically identifies that until when a row was valid and visible for transactions. On a row creation, end timestamp for every row is marked infinity. Means row is available for future transaction until how long? Don't know. Once a new version of this row is committed, value for end timestamp will be replaced with begin timestamp of newly created version of row. A row version which is never updated will always contain infinity as end timestamp. Statement ID is the identity of the statement which has created the row, while index link count specifies the number of indexes the row has. And final field in the row header are the pointer to the next row for the index. Total length of this field depends on number of total indexes on row. Readers don't block readers, so multiple users can access a row at the same time. Yeah, no locks, no latches. Even writers don't block readers, and if a user needs to update a row, in Memory OLTP engine will create a new version of targeted row for editing. Meanwhile, original row version will remain valid and visible for other transactions. But once changes are committed, begin timestamp will be changed for new version. As well as same timestamp is updated as end timestamp of last version of same row. This new end timestamp for a row version makes it invalid and invisible for future transactions. A dedicated process, garbage collector, is responsible to remove these invalid rows to reclaim memory. All future connections can only see and use this newly created version of required row. If a row is deleted, it is just marked invalid and invisible to transaction, and later on, garbage collector will reclaim memory by physically removing deleted row. What if two or more users are updating same row? Suppose a user A starts working a new version of a row to update SSN of an employee. And before user A has finished its changes, user B also needs to update same row by creating new version of row. If user B is quick and commits its changes first, then begin timestamp will change to current time, as well as end timestamp of last valid version. In Memory OLTP engine will mark first version as invalid, and invisible as new version with begin timestamp. 733.800 is available now. When user A tries to commit its changes, transaction will make sure if version it was working on is still valid. In our case, answer will be no. So, SQL Server will generate write conflict error and will roll back the transaction, making its row version invalid and invisible for other transactions. User A will be asked for retry by making changes in newly available valid version of row. Commit process for in-memory tables data is a nanoseconds game, and practically there are no or very less chances of write-write conflict. How SQL servers manage access to millions and trillions of rows, which exist in memory without any data page or extent boundary. For this purpose, range and hash indexes are used for quick access to these rows. New hash indexes are useful for direct access to rows. Hash indexes is simply an array of hash buckets which will contain hash keys to identify and access these rows. When we create hash index on a table column, SQL Server creates a hash value for each entry using specialized hash functions. These hash values are stored in already created hash buckets of hash index, which will be used as direct address for data rows. Same hash values generated by hash function for closely resembling column values is called hash key collision. Hash bucket for such hash key values will directly link first row only, and for next row with same hash key will be accessed by storing a pointer in first row and so on.